All right, zero exponents. These things are kind of strange. In general, any base to the power of 0 is equal to 1. I'll give you a quick proof. This is proof in bracket or in quotes because it's not a formal proof. It's more of an example. But I just want to look at, for example, a to the power of 3 over a to the power of 3. You'll recall from our division power rule that I can subtract my exponents because I've got the same base. So I end up with a to the power of 3 minus 3, which is a to the power of 0. Okay, and you're thinking, well, how's that relevant? I'm just going to tuck that away for a minute. What I'm going to do next is I'm going to look at this expression, but I'm going to write it a little differently. Okay, I'm gonna do the canceling method that we looked at in our second exponent law. Okay, remember I can cancel a terms in pairs, and every time I cancel an a term or a pair of a terms, remember I'm left with a 1, right? So I've got a 1 here times 1 times 1. 1 times 1 times 1 is just 1. Okay, so well, that's kind of strange. This same expression can be written two ways, right? I can write this as a to the power of 0, or I can write it as 1. Well, from this, we can kind of make a leap in logic and assume that a to the power of 0 is in fact 1. Okay, and that's sort of your mini proof for this power rule. So any base in general to the power of 0 is equal to 1. All right, so taking a peek at this first example, y to the power of 0, this is really just rewriting this first, or this in general representation of this power rule. So y to the power of 0 is going to be 1. Okay, nothing too crazy there. This guy, however, these things can get a little difficult, and really as long as you remember bedmass, you should be okay. So remember, bedmass tells you to do your exponents before your multiplication. Okay, so in this case, what we have here is negative 3 to the power of 0. Our base is actually 3. That 0 does not apply to that negative. There are not brackets there. So this exponent is attached to the 3, and afterwards we're multiplying by negative 1. Okay, so you got to remember to use bedmass here. Do your exponents first, then multiply by your negative. Okay, so in this case, we actually end up with 1 times negative 1, also known as negative 1. These things can be a little tricky, but let's look at another example here. So in this case, I've now got brackets around my base. I've got a negative 1 to the power of 0. So this 0 applies to both my 1 and the negative in front. Okay, so this whole base to the power of 0, any base to the power of 0 is 1. So we know this whole thing is going to be 1. But again, we're multiplying by this negative in front. Okay, so in this case, we've got a 1, and we're multiplying by negative 1. So of course, we end up with a negative 1 as well. Again, these things can be a little strange. Just remember bedmass. Don't forget about your brackets. And always do your exponents first and just multiply by whatever's in front. Okay, the last exponent law I want to look at quickly. This one involves negative exponents. Typically, in math, we like to write things with positive exponents. So this one just allows us to do that. What it says is take your base and write it as a reciprocal, so flip it. So in this case, we've got x over 1. We're going to flip this thing. We're going to make it 1 over x, and we're going to make that exponent positive. Okay? So that's one way of writing this. If you have another variable, for instance, x over y, same thing, just flip your fraction, write it as a reciprocal, and make that exponent positive. Okay, so taking a look at this one, the first example here, this says simplify by writing as a power with a positive exponent. Right now we've got a negative exponent, so that tells us to go to this law, flip your fraction, which we can write as 2 over 1. We make that exponent positive. We could simplify this as just saying 2 to the power of 2. Same thing in this case, but we're going to look at this general example up here, or sort of this general form of this law. We're going to take our base, our fraction, and we're going to flip it, and we're going to make that exponent positive. Okay, so you may or may not have seen this in your studies, but this is definitely useful as we move on into more advanced math.